Hello everyone, in this video we're going to look at the atom workshop answers. So here's our first question. Atoms contain particles called electrons, protons and neutrons, and the diagram shows an atom of boron. So the most important words here are electrons, protons and neutrons, and of course we're looking at the atom of boron. So boron has a atomic number of 5, which is the number of protons, which you can see here in the nucleus, and the number of electrons. Again, you can see them on the diagram. Boron also has a mass number of 11, which is the number of protons and number of neutrons added together. So if we do this quick calculation and we take the atomic number away from the mass number, we get 6 neutrons, which again you can see in blue on the diagram. So the question gives us sentence starters and we have to fill in the missing words. So let's start with the first sentence. It says the nucleus of a boron atom contains 5, and from our diagram we can see that we have 5 orange dots, which are our protons, and 5 X's, which are our electrons. So in here we are asked about the nucleus. So in the nucleus we have 5 protons and 6 neutrons, as we just figured out. There are also 5 something in the shells around the nucleus. As we said, there are 5 X's, 5 electrons, and they are in our shells. So the missing word here would be electrons. We have 5 electrons in the shells around the nucleus. And lastly, the particles in the atom which have a positive charge are called, and they are protons. Protons are positive, electrons are negative, and neutrons are neutral. Our second question says the following diagram, which is right here, shows the structure of an atom. And then we again have to finish our sentences with the words that are given. One of them is going to be left. So let's start with the first sentence. The particles labeled X are called electrons, as we just established. They are in the shells. The part of the atom labeled Y, so in the center, is called nucleus, and it contains particles called protons and neutrons. In the nucleus we have protons and neutrons. There's also part B to this question, and it says draw a line from each particle to the charge of that particle. So here are particles, proton, neutron and electrons, and here are the charges. So proton has a positive charge and neutron has a 0 charge. It doesn't have a charge, that's why our nucleus is positive, and the electrons around the nucleus in the shells are negative. Question 3. The following diagram shows an atom of lithium. And sentence starters again. Particle X is an... And here we're going back to our previous videos where we said protons and neutrons make the nucleus and electrons are around in the shells. Here X is around in the shell, so it must be an electron. Particle Y found in the nucleus is A, and here we have to look close at the atom of lithium. So lithium has an atomic number of 3, which is the number of protons, and the number of electrons, and it has a mass number of 7, which is the sum of protons and neutrons. So if we do a little bit of maths here, we can find out that the number of neutrons is 4. On a diagram, we have 4 black dots and 3 white dots. So black dots representing the neutrons, and Y is pointing at the black dot, which means our particle Y must be a neutron. The second part of this question says use the diagram to explain why lithium has a mass number of 7. So looking at the diagram, as we said, it has 4 neutrons and 3 protons, and they all have a mass of 1, which gives us 7. Question 4. Nitrogen has 2 stable isotopes, nitrogen 14 and nitrogen 15. Describe how these isotopes are similar to one another and how they are different. So we're looking at the similarities and differences, but let's first define isotopes. So isotopes are atoms that have the same number of protons but a different number of neutrons. So if you look at our nitrogen atom, always will have 7 protons, as the number of protons stays the same. However, our difference will be that nitrogen 14 has 7 neutrons, and nitrogen 15 will have 8 neutrons. Now we're looking at question 5. A sample of lithium is found to contain 2 isotopes. So we're looking at isotopes again. Calculate the relative atomic mass of lithium and give your answers to 3 significant figures. We are given a table and an equation, and now we just have to substitute the numbers into the equation. So let's see. The mass of the first isotope is 6, lithium 6, and we multiply it by its abundance, which is 7.59, and the same with the second isotope, mass of 7, and its abundance, and we divide it all by 100. So now I just substituted in the numbers. So 6 times 7.59 for lithium 6, and 7 times 92.41 for lithium 7, and divide it all by 100. And this would give us 6.92 to 3 significant figures. And there's also part 2 to this question. State the difference between the atomic structures of lithium 6 and lithium 7. So this question is about isotopes, and we have 2 isotopes of lithium here, so they should have the same number of protons and different number of neutrons. And if we look closer at the lithium atom, we can actually see that the nucleus of lithium 7 would have 4 neutrons, mass number minus the atomic number, which gives us 4 neutrons. However, the one of lithium 6 would have a 1 less mass number, which means we would have to do 6 minus 3, which is the atomic number, and it doesn't change, and it gives us 3 neutrons. So the difference between them is the number of neutrons. Our last question, question 6. Potassium has 3 stable isotopes, potassium 39, potassium 40, and potassium 41. Part I asks us to compare the nuclei of each of these isotopes. So here is our potassium atom, and it has a mass number of 39 and atomic number of 19. So if we're comparing these isotopes, they all will have the same number of protons, as the atomic number doesn't change. So they will all have 19 protons. However, their number of neutrons will change, and our potassium 39, so our first isotope, will have 20 neutrons, as 39 minus 19 is 20, and then a potassium 40 will have 1 more neutron, and potassium 41 again will have 1 more neutron, so 21 and 22. And the very last bit, part II of last question, says use the information to calculate the relative atomic mass of potassium. Record your answer to 3 significant figures. Here is a table again and our equation, and now we again have to just relate these two. So our equation says that we have to multiply the mass by the percentage isotope 1, which would be 39 times 93.1 for our potassium 39, and then do the same with the second isotope and the third isotopes. And now we just put in the numbers into the equation. So 39 times 93.1 for our first isotope, 40 times 0.0122 for the second one, and 41 times 6.88 for potassium 41. And we divide it all by 100 to give us 39.1 to 3 significant figures.